Okay, up on top of this document, we're doing 6.1, okay? Now on top of this document, you have inequalities, okay? Greater than or equal to. Now some other words that mean that is at least, starting at, goal. So I've wrote that on the piece of paper because I'm going to need this when I work on my assignment and when I work through the examples. Less than or equal to. At most, no more than, limit, have. Okay? All those mean less than or equal to. Okay, without the bar, it means greater than. Pretty much the only thing that would be synonymous with that means more than. Okay? And then that means less than. Now, here are the examples. First section, determine whether the number is a solution to the inequality. It's a yes or no answer, but you can't just guess, okay? So here's the first problem. It says 2x plus 1 greater than negative 3, x equals negative 1. What I want you to do is simply put the negative 1 where the x is at and put a times so the 2 and the negative 1 have an operation. Now all the operations are on this side. So I line up my symbol, negative 3. Now you can, on this side, you can either just simply type in 2 times negative 1 plus 1, or put negative 1 down, or you can multiply first. 2 times negative 1 is negative 2 plus the 1. Negative 2 plus 1 is negative 1. Okay, what's bigger? Negative 1 is the bigger number. The sign has to open up or eat that number for it to be yes. And it does, so yes. Negative 1 is a solution. One of many solutions, but it's a solution. Okay, next one we got 13 minus 7y less than or equal to 6. Y equals 1. Okay, so I put a 1 over the y, and that means 7 times 1. I'm not a big minus fan in algebra, so plus negative. If you want to leave it minus, that's fine. You can either go 13 plus 7 times 1. Whoops, my bad. 13 plus negative 7 times 1. And put 6 down and roll with that. Or you can take your negative 7 times your 1, that's negative 7, so 13 plus negative 7. And then I add 13 to negative 7, that's 6. Okay? So we get the same number, 6 and 6. So it doesn't, there's not a bigger number, the line's there. If the line's there and I end up with the same number, they're equal, then yes, that's a solution. If that line was missing, then it would be no. But 6 less than or equal to 6, yes, they're equal, so it's a yes. Okay, next one, negative 4x minus 3 greater than or equal to negative 17. Okay, so all the actions here, I want to check if 5 is a solution. So I put 5 over the x, so it's negative 4 times 5 plus negative 3. Okay, you can either punch the whole expression on your calculator, or you can multiply negative 4 by 5 to get negative 20, and then plus negative 3. Negative 20 plus negative 3 is negative 23. Okay, greater than or equal to negative 17. Now, negative 17 is the larger value, but it's not opening up towards it like it should, so the answer is no, that's not a solution. Okay, and then on this section we have 10 minus x divided by x less than or equal to negative 60, x equals 0.2. So just put a 0.2 over your x. I know that doesn't look pretty, but that's okay. So 0.2. So the actions on this side, I know I have negative 60 over there. Figure out what goes over here. So first, when you have this division line, you need to do the operation on top first. 10 minus 0.2 is 9.8. If you want to go plus negative 0.2, that's fine. It's still 9.8. Then we take the 9.8, divide it by the 0.2, and it's 49. Because when you're dividing a number by a less than one whole, the number actually gets larger, 49. Okay, positive is always bigger than a negative, but it's not opening up towards the 49. It's not eating the 49 like it should, so the answer is no. 0.2 is not a solution. What are the solutions? Not my job at this point. Just figure out if that is. Okay, now the next part, graph each inequality. You're using a number line to graph it. You're not making a coordinate plane. Okay, there's two basic rules you can always rely on. They work every time. If the sign eats the letter or opens up towards a letter, it goes this way. Letter or variable, whatever you want to call it. If it eats the number, then it goes the other way, the less than direction. Okay. Now, some of these can be, especially the ones where the variable comes after the number. Okay. First one's fairly basic. Okay. Variable number. So I see a 1, circle. We don't fill in the circle because the equals to line's not there. Now, it eats the number. So if it eats a number, it's going this way. Okay. Now I'd like you to label every time you do that. Okay. X1 has to eat the 1. Okay. That's the answer right there, that whole thing. Okay, next one. A greater than or equal to 0. So 0, I guess 0 is the number. So I circle the equals to lines there. I fill it in. Eats the letter. Eating the letter takes it this way. So at this point, I know what you're thinking. You're thinking, well, that says less than, so I go this way. That says greater than, I go this way. Easy enough. But the next one kind of throws a monkey wrench into that. -2 greater than or equal to x. So -2, circle, fill it in, because the line's there. Now, simple question. You see greater than, but you're not actually going to do greater than. Here's why. Does that sign eat the number, or does it eat the letter? It eats the number, okay? I know that's a greater than sign, but it eats a number, so it goes this way, okay? So that's the appropriate graph. Now to label it, you can either copy down what you have, that I'll accept that, or if it's driving you nuts, you'd put the x in the -2. If you want to put the x first, that's fine, but you still got to eat the -2. It still has to open towards a -2. So in that instance, to make it open to the -2, the sign flips, okay? So either one of those work. You don't have to write them both. You either put this or this, okay? Because if I wanted to put the x first and the -2, that sign still has to open to the -2, which means it would flip around. Okay? X is less than or equal to -2. -2 is greater than or equal to x. Okay? I'm fine with either one, but just because you see greater than does not mean you automatically go to the right every time. Sometimes yes, but other times no. Okay, next one. F greater than -3. So we have -3. This one, circle, we won't fill it. It opens up towards the letter, so that means the letter can be all numbers greater than. So you just put F, -3, open the F. Okay. Okay, next one. This one's another one where you could get, if you don't follow the rules. Okay. So you got 8. You're going to fill in your circle. Opens to the number, okay? So it eats a number, it's going back this way, despite the fact that's a greater than sign, okay? Now when labeling it, you can either write this, just copy it down, Or if you have to put the b first, if you're one of those people who has to have that variable first, it still has to open up towards the 8. Okay? So either this or this. Okay? But if I switch the order, the sign's got to be reversed so that it still eats the right number. Okay? So pick one or the other, whatever you like best. It means b would be any number less than 8. 8's greater than b, so b itself would be any number going this way. Okay, next one. X greater than or equal to -2. So I plot -2. Circle, I fill it in. Eating the letter, so x then the letter would be greater than 2. So x greater than or equal to -2. Relatively easy one there. Now again, the order's kind of jacked up, which is why we have a set of rules that will work every time. Okay? I know that's a less than, but guess what? It eats the letter, so the letter can be greater than -9. Okay? Eating the letter goes this way. So you can write that one of two ways. You can just copy down what you have. I'm fine with that. Or if you need to put the C first and then the -9, that's fine, but you just got to open it towards the C, which means the sign would flip. Okay? Whatever way makes more sense. But this is the way the graph goes. When you label the graph, you can either go with what you had, or if you want to put the C in the -9, that's fine, but you got to open it towards the C. Okay, and then the next one, A greater than or equal to -20. Circle, fill it. Eats the letter, so it goes this way. When the letter's first, it's going to be standard, okay? It's going to greater than goes this way. But when that number comes before the letter, we really got to focus on these rules, okay? So, A greater than or equal to -20. Okay, next one. Write an inequality that describes the situation. Okay. Now I'm going to flip over this back side. You can look at the top of the document for help if you want, because I had all this on the top of the document. You're writing an inequality. You're not solving it though. Okay. So you just got to write stuff down. You don't calculate anything. Prices for rides start at $19.99 with the P variable, so I use P, then $19.99. So start at, well, they're starting at, that would be synonymous with greater than or equal to. Okay. Next problem, the speed limit on the interstate is 75 miles per hour, so I use the S variable for speed limit. Well, the limit is less than or equal to. Okay, you don't have to graph these. A person must be at least 35 years old to be elected President of the United States. So A, 35. At least. Well, here's at least, so greater than or equal to. Okay, and then every object on Earth travels less than 186,000 miles per second. So B, 186,000. Less than, well, less than, pretty obvious what I'm going to put. I'm going to put the less than symbol without the equals. Now, if I were to graph these, okay, each the letter be going this way, so I'm greater than 1999. Each number this way, less than 75. Each the letter this way, greater than 35. Each a number this way, less than. It's pretty standard because in all these I wrote the variable first. It's when the number comes before the variable that you really got to focus on the rules. Okay, next one. My goal is to earn $300 selling cookies and donuts. Cookies cost 50 cents each, C. Donuts are 75 cents each, D. Write an inequality to represent my goal. This is essentially the same thing I was just doing. It's just a little longer. I'm not calculating anything. It says write an inequality. It doesn't say I have to solve. Okay? I'll repeat that again. Write an inequality means I don't have to solve. Okay, the word goal is highlighted because on the top of that document, goal insinuates greater than or equal to. Okay? Your goal is $300. Now, I'm going to be doing that, couple things I'm going to be doing. I'm going to be selling cookies for 50 cents each, but I don't know how many I'm going to sell. So I put C or times C, whatever. Plus, I'm also going to be selling donuts. Those are 75 cents each. So D or times D. And that's it. You just write it. You don't solve it. So that's what those directions mean. My goal is to earn $1,000 selling t-shirts and hoodies. T-shirts cost $9.99 each. Hoodies are $20 each. $9.99 each for T. Hoodies are $20 each H. Write an inequality to represent my goal. Okay, goal. Goal is greater than or equal to, because you want to meet a goal, but you can also exceed the goal too. So greater than or equal to. So $1,000. So what am I doing to make $1,000? Well, I'm selling t-shirts for $9.99. Not sure how many of them I'm going to sell, so T, capital T. Don't put lowercase, it looks like a plus. Okay, I'm also selling hoodies along in addition to that, so 20 H. Write the inequality. You don't solve it. You're doing the same thing here that you're doing up here, just it's a little more complicated. Last set of problems. 5 pounds of pasta serves 14 people. Okay, pounds is X, people's Y, because if I were to label that a rate, it would be people per pound. How many people can 1 pound serve? People per pound. We have 17 pounds of salad. Okay, write an inequality. Sorry, I need to add to that. It says write and solve an inequality that represents how many people we can serve with what we have. So what I need to do, unlike what I'm doing here where I just write the inequality, say good, it doesn't say just write an inequality, it says write and solve an inequality. I put that in big caps so you can see it. So you have to solve the problem and then write the final answer as an inequality. Okay? So I'm going to set up my units box with the table. Okay? So pounds and people. Pounds is X, people's Y. I told you in that problem because it's kind of complicated without it. Then it's people per pound. Always the Y per X. Pound is singular. They did not give me the people per pound. Now I could figure it out, but let's go over here. Maybe I can do it a simpler way rather than have to not make the line. I kind of like that cross multiply and divide thing. It goes quick. So X is pounds, Y is people. I will not be doing the 0, 1, 2 here because I don't have a rate of change yet. So I put 0, block it. Now I put what I know. 5 pounds, 14 people. 17.5 pounds, I don't know how many people. That's going to be our X or Y, whatever letter you put. I don't really care. Now if I have 0 pounds of pasta, guess how many people eat? 0. So the 0, 0 at the beginning means I go straight to my proportions. Okay? Put the Y unit on top because it's people per pound. People, pound. People, pounds. Okay? So I know that 14 people, 5 pounds. I know that 17.5 pounds, but I don't know how many people. Okay? So X. Cross multiply and divide, you get your answer. So 14 times 17.5 divided by 5 is 49. So 49 people. Now you need to write it as an inequality. Now would it be greater than or less than? Well, let's talk about this. The word have is in big capital letters. Have means less than or equal because you cannot go over the 49 people with how many pounds you have. Okay, so that is our answer. So write and solve an inequality means solve the problem, but then write the answer as an inequality. Okay, last problem. A florist is making centerpieces. 5 centerpieces require 24 roses. We have 96 roses. Write and solve an inequality for how many centerpieces we can make. So we're not just we're solving the inequality, solving the problem, writing the inequality. So again, let's make our units box. We have roses and centerpieces. So I got 5 centerpieces, 24 roses. So it'd be roses per 1 centerpiece. Or it'd be multiple roses and 1 centerpiece. So roses per centerpiece. So Y is roses, X is centerpieces. So per roses per centerpiece. I don't have that. It's not 24. Okay, that's for 5 centerpieces. So I make a table. So you've got centerpieces for X, roses for Y. Block it 0. Okay. Don't do 0, 1, 2 because you don't know the roses per centerpiece. I don't think I'm going to need that. 5 centerpieces is 24 roses. We have 96 roses, and I don't know how many centerpieces we have. Okay, if I'm making 0 centerpieces, I don't need any roses. So that 0, 0 means it's proportional. I make my proportions. Okay, so roses, centerpieces, roses, centerpieces. So I know that 5 centerpieces require 24 roses. I have 96 roses. How many centerpieces would that be? I'll put X. If you want to put Y, I don't care. So 5 times 96 divided by 24 is 20. 20 centerpieces. But you got to write it as an inequality. Now that word have is in big caps. The word have means less than or equal to. So X is less than or equal to 20 centerpieces. Okay? Because you can't go over what you have. Okay? You can go under it because you'll have some left over. But that is how you need to be writing your answer. Okay? In inequality form. Now on the assignment, refer back to your notes. 1 through 4, you just plug in the number in, decide if it's yes or no. Graph the inequality. Remember, eats the letter this way, eats a number that way. 9 through 12, you're writing the inequality, you are not solving it. And then number 13, you need to solve the problem and write your answer in the form of an inequality. There's that word have. Okay.